Hi guys, Nexi here, back with another video, and today we're gonna review FLSUN S1 Ultra high-speed Delta-style 3D printer with impressive specs and insane print speed. In this video we're gonna test print speed, noise level, print quality, flow rate, and see how well this printer performs. And for the bonus, we're gonna try to silent the printer down, we're gonna test the maximum flow rate with a Bondtech high flow nozzle, and we're gonna try to smooth the print surface with the TL smoothers. We have a lot to cover, so stay tuned. Welcome back guys, and thanks for tuning in. This enormous sized 3D printer is FLSUN S1, the ultra fast Delta style 3D printer. The speed of this printer is insane, it's 1200 mm per second. Acceleration is 40,000 mm per second square, and the flow rate is mind-blowing 110 mm cube per second, which is ridiculous. On paper, this thing is a beast, and nothing comes even close. The print volume is 320 mm in diameter by 430, while external dimensions are 55 by 60 by 103 cm. With a weight of 50 kilograms or 100 pounds, this machine is the biggest, the heaviest, and the fastest 3D printer that I ever tested. Now, let's run some features. The S1 have auto leveling, filament runout detection, intelligent 1000 watt heat bed in 2 heating zones, built-in HD camera with a time-lapse feature. It has a closed-loop step motors that monitor every step. Next, we have a dual gear direct drive extruder with 80 watt high flow hot end up to 350 C. It has a crazy fast 40,000 RPM cooling turbo fan. It has a Wi-Fi, built-in LiDAR with the sensors on the print head. Next, it has some AI features like first layer detection, debris detection, clog, and spaghetti detection. That's not all. We have UPS on board, large high-res screen, and the last but not least, there is a built-in filament dryer with a spool scale so that you can see remaining percentage of the filament on the screen, which is pretty cool. On paper, this machine is a beast in every way, and we're gonna test that and see if FLSUN S1 lives to its own expectation. But first, let's do a quick unboxing. The S1 comes in a huge shipping box that fills up pretty much the entire desk. With a weight of 50 kilograms, this is a two-man's lift. Since my wife was busy with the kids, I cut open the box in a vertical position and slide the printer slowly on the desk. Once I remove all the packaging and the plastic cover, I slowly remove all the plastic straps that hold the glass panel into place. Beside the printer in the box was the screen assembly, power cable, and 500-gram high-speed PLA filament. On this side we have the toolbox with the parts, screws, spare Teflon tube, hot end with a nozzle, hot glue, and we have a greeting letter from FLSUN, some quick instruction book with specification, assembly setup process, service policy, and a big glass front door. Assembly of this 3D printer is very easy. First step was the screen, then the hinges, and the glass door. After that I installed the glass door, I removed 3 safety clips from the arm belts to free up the print head. That's pretty much it. Then I installed the filament, and I plug in the power cable and flip the main switch. When the system boot up, I set up language, Wi-Fi connection, and start with the calibration process, which takes around 10 minutes. Calibration was cool to watch, as during calibration process, the printer will calibrate the motors, vibrate the print head in a different frequency, and learn the curve to compensate it. Then it will do the heat bed leveling to check the flatness of the build plate in a different positions and store the measurements in a firmer so that you can get the perfect first layer every time. Now the calibration is complete and we are ready to print. But before that, let's do a quick overview. In my opinion, design of this printer is beautiful. The combination of black and silver color with this black tint on the glass doors give this printer very cool and futuristic look. The S1 frame is all metal and it's very heavy. Build quality is solid and it looks premium. Except this silver plastic cover in the middle and this black curved housing for the screen, Everything else around is made of metal and glass, and it feels high quality. This printer is fully enclosed and it traps the heat inside pretty well. The long effector arms are made of carbon fiber. Up there on the ceiling we have a closed loop stepper motors, which monitors every step sent to the motor to make sure that you never get a skip step or the shifted layer. Drivers are 5160 and the machine runs slightly modified clipper with accessible configuration file. The S1 print head have a direct drive dual gear extruder with 80-watt ceramic high-flow all-metal hot end, with a hardened steel nozzle that can reach up to 350 degrees Celsius. Here, right next to the nozzle, we have LiDAR sensor, which is used for the first layer detection, accuracy calibration, and the flow calibration. The heat bed on the S1 is quite big. It's 320 mm in diameter, and despite its large size, it heats up extremely fast, thanks to 1000 watt AC heater and installation underneath, so that you can start to print in no time. On top of the heat bed, we have magnetic flexible build plate, which works great, and it's super easy to remove prints from it. Just flex it when it's cooled down and the prints will pop up. The maximum print volume of this printer is quite large. It's 320 in diameter by 430 mm. But since this is the Delta 3D printer, keep in mind that if you want to use the entire surface of the build plate, the maximum print height is about 384 mm and not 430. Keep in mind that FLSUN slicer will not warn you for this and your print will fail, at least for now. Here on the side we have a nice enclosure lights and a camera which is used to monitor your prints, make time-lapse videos, and for AI functions like spaghetti and debris detection. During my testing, I have a both positive and a negative experience with the AI features on this printer. The functions like filament runout detection and clog detection indeed works reliable. The spaghetti detection works for most of the time, but if the filament is black color, then this function will not work reliable. Other AI functions like the first layer detection and debris detection works for the most of the time. The screen on this printer is beautiful. It's large, high-res and very responsive, with a good contrast and nice viewing angles. The software interface is nice and polished, and I found user interface to be smooth and easy to navigate through the menu. You can copy your files to your USB stick and preview your time-lapse videos, which is cool. During printing, the screen will show you the print temperatures, how much filament you have left, print speed, remain time, and other useful information, which is nice. This 3D printer have a built-in UPS, which in case of power loss can move the print head, save the print process, and continue after the power is restored. This function works well and it's very useful if the power loss is quick. Otherwise, when the heat bed cools down to the room temperature, the prints can loose from the build plate and fail. To prevent this, you can flip the build plate on other side and use the glue stick which is supplied with the printer. The S1 have a built-in 50-watt filament dryer that you can operate over the screen and set desired drying time. On the screen you can see the temperature and humidity, and the dry is pretty effective. Only problem is the temperature is fixed at 60 degrees Celsius, which you cannot change. This is a bit too much for PLA and too low for some other high temperature filaments. I wish that we can set the desired temperature manually, and I hope FLSUN will add this in a future update. Now let's talk about the print quality. At first, I printed 3D Benji in a white high-speed PLA filament that comes with the printer. And to my surprise, the print quality on S1 was really good considering that this 3D Benji was printed in just 8 minutes, which is very impressive. Then I print 2 more and the print quality was consistent and it was very good as well. Then I print few more prints, all from the G-codes that comes from the printer. There was a model of the lighthouse, printed just in 1 hour, model of the Viking, and the flower basket, who the S1 printed in record time. And all of these prints looks very good to my surprise. I checked the models in close-up, but with this white color PLA filament, it's very hard to see the layers. So I switched to the black high-speed PLA filament, and I print again 3D Benji in just 8 minutes. Now we can see the layers much more clearly. Well, not bad at all. Very impressive high-speed print results from S1. Other than some vertical fine artifacts that are visible under specific light angle, the print quality looks really good. Here you can see examples of two 3D benches printed in 8 minutes with the G-codes that comes with the machine. The one on the left is printed with a high-speed PLA filament and it looks pretty nice, but the one on the right is printed with a standard PLA and it looks much worse. So if you want to print at full speed, you will need the high-speed PLA filament. Then I print out this vase in a black color and it looks great. It's a nice and solid and layers bonded so well. The print surface is smooth and my only complaint was this seam where the all layers meet together. That could be tuned a bit better. Then I switch to the light gray high-speed PLA filament and I print these two models. One is a model of the dragon and other is a boost of the Deadpool. Dragon is printed at 300% scale in just 2 hours and 46 minutes, which is really impressive. I did not use supports for this print, just the standard settings without any tweaks. So overhands on some places are not the best. But overall print quality is really good and the print surface was pretty nice too. Next up is a Deadpool, printed in just 2.5 hours, which is incredible. Print quality on this model looks quite good. Some overhands here and there, but the print surface could be a bit better as the artifacts now are visible on this model. But again, on other hand, I cannot complain too much consider how incredibly fast this model is printed. If we compare standard 3D printers, it will need more than 15 hours to print this model, and with S1, it only took 2.5 hours, which is incredible. Now, to speed things up, I choose two models for print comparison, so we can compare the print quality. I choose the model of the bearing and this model of the dragon. Keep in mind that everything is printed with the standard print profiles in FLSUN slicer. Now if we look at the bearings first, I will say that the best and very similar surface quality have PLA and ABS prints. And then the PTG and TPU have a worse print surface as they are glossy filaments, so the artifacts are more visible. Keep in mind that the PLA prints are printed in just 23 minutes, which is much faster compared to the other filaments, which took much longer time to print, especially TPU. Now, if we switch to the model of the dragons, printed in a PLA, PTG, ABS and TPU filament as well, the story is a bit different. Since this model is much more challenged to print, the ABS print quality looks the best, and then PLA, which was the fastest, followed by PTG, and the last is TPU, which looks terrible due to the too much flexing during the printing. The artifacts on the print surface are visible on all dragon models, but with the PTG it's most noticeable due to glossy characteristic of the filament. So depending on what you're printing and how fast, these fine artifacts will be visible on your prints. Sometimes more, sometimes less, depending on your print models and print speed. For the record, I did install the TL smoothers to see if they can smooth out the signal from the stepper drivers and give us a bit better surface quality. But according to my testing, I did not see too much of the improvement with or without them. The print surface on all printed models looks exactly the same to me. So I guess we have to live with these artifacts, at least for now. Now in case of accuracy, the S1 performs very well. At the first I print this gear from MakerBot, which looks good and spins nicely. Then I print few more benchmark tests and a few tolerance cube, and check the print accuracy, which was pretty good too. All the pins was free, and only pin with the 0.1 mm tolerance was stuck, which is pretty good. I did automatic print accuracy calibration and the flow calibration on the print menu, and the results was good and it measures well, which is kinda surprise for the Delta style 3D printers. For the record, with all prints in this video, I use the standard print profiles in a FLSUN slicer, which are kind of okay for the general use, but they are not perfect. I will suggest that you fine-tune the print settings according to the model that you're printing to get the best results. Also, I'm not a huge fan of the FLSUN slicer, and recently I installed the Orca slicer and load some print profiles from the GitHub, My plan is to test them out and switch to the Orca slicer in the near future. Right after that I started my first 3D Benchy print. My first expression was wow, the S1 just blasted through the 3D Benchy, which was very impressive. But what was not so impressive was the noise that was coming from the part cooling fan. Man, this printer is loud, very loud, especially if you're printing something with the cooling fan set to the max speed. You see, in order to print this fast, you need to cool down the filament as fast as possible. And here is where this powerful high pressure turbo fan coming into the picture. This powerful fan is mounted on the top of the printer, and at 100% speed, it spins at whopping 40,000 RPM and shoots down the air through this flexible tube straight to the hot end. The airflow is very high and the cooling is very effective, but the noise coming from this suction grill is way too loud. Luckily, the FLSUN leaves the silencer that you can print from the USB stick that comes with the printer. With the silencer and the fan speed set to 100%, the noise level drops from 66 down to 59 decibel, and the silencer cut that high pitch noise to much more ear-tolerant noise. If you set part cooling fan to 50%, the noise level drops even more to about 51 decibel, which is not too bad for the PTG and ABS printing. One update after a few weeks, I found this extra silencer on the S1 Facebook group, which lowers the fan noise even more. So when you place this new silencer over the first one, the noise level drops from 57 decibel at 100% fan speed and to 48 decibel with a 50% fan speed, which is not too bad and I can live with it, but not sleep next to it. I highly recommend this silencer, and when you print it, make sure that you choose organic supports and not the grid supports. The organic supports are like a tree, they are much easier to remove and they can reach the top section of the model through the holes on the model, which is pretty awesome. Keep in mind that you will need some small pliers to remove the supports on the top and install this silencer. Your ears will thank you. And now let's talk about the speed. The main focus point of FLSUN S1 is high-speed 3D printing. The FLSUN claims that this machine can reach max speed of 1200 mm per second, but if we look closer to the default print profiles, the 1200 mm per second is actually a travel speed, not actual print speed where the filament is extruded. The default print speed for PLA profile is set to 500 mm per second and infill is set to 800 mm per second, where only the travel movements is set to whopping 1200 mm per second. This is a bit misleading, as you might think that you can print with that speed, but on the other hand, travel movements are technically part of the actual printing process, so you take it as you like it. Don't get me wrong, even the 800 mm print speed and 1200 mm travel speed is insanely fast, and not even one desktop 3D printer on the market that I know of can print or move that fast, not even close. Similar story goes to the acceleration speed as well. Default acceleration speed is set to 40,000 mm per second square, but the printer uses maximum acceleration up to 32,000 mm per second square, and only during travel. Again, don't get me wrong, this is still more than 3 times faster than the Bamboo X1 Carbon, but technically you never see 40,000 mm per second during printing. And now we are coming to the main event, and that is the flow test. On paper, FLSUN claims that this machine is capable of achieving a flow rate of mind-blowing 110 mm3 per second, which is almost 4 times higher comparing to any other high-speed machines on the market. Now, if you look closely on the S1 hot end, indeed it looks impressive. We have this large 80-watt ceramic heater on it, and inside the hot end, we can see that it looks very similar to the high-flow CHD nozzle. Anyway, looking at S1 hot end, it looks that it might be able to reach the claimed flow rate, but certainly not with the standard V6 nozzle, which I know for sure it cannot reach claimed flow rate. Also, I'm not sure what material this heat block is made of, but the magnet will not stick on it. Could it be aluminum? I can't tell. If it's indeed aluminum, then abrasive filament can damage the heat block over time. Alright, after a few hours testing, the maximum flow rate with the two different high-speed PLA filaments and the standard nozzle, I was getting the flow rate around 42 to 45 mm3 per second before the print's quality degrades. And only with the FLSUN high-speed PLA that comes with the printer, I was able to achieve maximum flow rate of 50 mm3 per second with a maximum print speed of 600 mm per second. These numbers are indeed impressive, but the flow rate is far from the claimed 110 mm3 per second. To put this flow test to the limit, I got some Bondtech high flow CHD nozzle and I installed it on my S1. This unique design high flow nozzle should give us a quite boost in the flow rate. I repeat the flow test with a high flow 0.4 mm Bondtech nozzle, starting from 40 mm3 per second all the way up to 110. This time the maximum flow rate that I achieved was close to 80 mm3 per second, before quality degrades. Not bad for 0.4 mm nozzle. Let's move to 0.6 mm nozzle this time and try again. My next setup was the 0.6 mm high flow nozzle from the Bondtech. So I reset the benchmark flow test again and I started. This time I set starting position from 60 mm3 per second all the way up to 110. During testing, I gotta say that I never seen filament spool spinning that fast before. The print head is flying through its print and we are very close to the maximum flow rate now. The print is almost complete. Any moment now. There, we hit it. We hit the peak flow rate of 110 mm3 per second just before the print was complete. Awesome. Alright, let's check the print quality. Remember that we start from the 60 mm3 per second and up to 110. We have some holes on a few places, but if we look closely, the print quality is actually pretty decent and usable even at those extreme high flow numbers. So, to conclude, you can reach the claimed flow rate of 110 mm3 per second, but not with a standard nozzle. You need a genuine high flow 0.6 mm nozzle from Bondtech and you can reach this insane flow rate, if you ever need it. For the record, I also tried some cheap high flow knockouts nozzle from AliExpress, similar to the Bondtech, but it didn't go so well with the S1. I barely hit some higher flow numbers over the stock nozzle and it even clogged my extruder twice during testing. I think the problem with this knockoff nozzle is that the wall of the insert are just too thick in the middle and the surface of the insert is flat. So when you install this nozzle, it covers the hole on the S1 heat block and restrict the flow. So don't use this knockoff nozzle on the S1. Go with the genuine Bondtech nozzle and have free mind without clogs. And now some feedback and the final words. Well guys, I spent 5 weeks testing this 3D printer and my overall experience is very positive. On the hardware side, this 3D printer is really impressive, but where it lacks to be perfect machine is the software. I test 3 different firmwares on my S1 and I send my feedback to the FLSUN. Indeed, they listen and make the changes of the latest firmware, which is great. AI features works much better now than before. Time-lapse videos are fixed now and the files are not overwritten anymore, which is good. My only complaint right now with this machine is the filament unloading procedure, which can create long tiny string and cause potential filament jam and clog the extruder, especially if you don't have experience with 3D printers. What should the extruder do instead is to purge the filament through the nozzle first and then retract and pull back the filament as fast as possible. To fix this issue, I edit the code and fix the issue by myself, instead of waiting for the next firmware update. Other than that, the S1 now is much better machine than it was 5 weeks ago, and I hope that FLSUN will continue to improve S1 software and print profiles. So in the end, can I recommend S1 3D printer? Well, if you have space for it, and you don't mind the fan noise, you like to tweak stuff and you're willing to spend some time to fine-tune print profiles and find that perfect balance between super high speed and your acceptable print quality, then sure, go for it. I think that S1 is an amazing 3D printer with a great potential, and I personally love it and I enjoy every second of using it. But if you don't share the same mindset, then I suggest that you look for something else. Alright guys, I hope that you liked this video and found it useful. Link of this 3D printer you can find in a video description. Feel free to leave a comment. Thanks for watching and I see you next time. Bye bye.